When you substitute x equals 0 into the equation y equals ax squared plus bx plus c, you get y equals c. So the y-intercept of a quadratic function is c. You can use the axis of symmetry and the y-intercept to help you graph a quadratic function. For a quick arbitrary example of what that means, check this out. Let's assume that we use the tools we have to find the vertex of a parabola. So I'll just label that with a V for vertex. And then you let C inform you of the y-intercept. And you find, say, a y-intercept here. Well, keeping in mind what we know about the symmetric nature of a parabola, we know that there'll be a mirror image point here, and we can therefore sketch, sketch the parabola from those 3 points. But through example problem 1, or in example problem 1, we'll walk through the process of actually completing these steps with, well, let's get started. Example problem 1, graphing y equals ax squared plus bx plus c. What is the graph of the function y equals x squared minus 6x plus 4? Well, step 1, find the axis of symmetry and the coordinates of the vertex. I would just call that step find the vertex. Along with the vertex, as you'll see, you likely already know, comes the axis of symmetry. So find the vertex, step 1. Y equals x squared minus 6x plus 4. Well, we know that the x-coordinate of our vertex is negative b over 2a. And that's definitely something you should have in your notes. You should also be familiar enough with it that you don't need to refer to those notes, but they're there to study or just in case. Negative b over 2a in this case will equal, be careful, b itself is negative 6. So now we're talking about the negative of negative 6, which of course is positive 6 over 2 times a. Even though we don't see a written here, the coefficient of our quadratic term, it's a 1. And therefore, our denominator is 2 times 1 over 2. And that 6 over 2 reduces to 3. So the x-coordinate of our vertex, is 3. Now to find the y-coordinate, we substitute 3 in place of x in the original equation. Y equals, it's going to be 1 times 3 squared minus 6 times 3. I really like the parentheses when inserting a value for x. Plus 4. 3 squared is 9. Minus 18 plus 4. 9 minus 18, negative 9 plus 4, and that's negative 5. A quick check against what the book found. Looks good. So now we have the vertex of our parabola. But if you recall from my quick sketch earlier, we'd like to find one more point. And a convenient point to find is the y-intercept. So you can see I've transferred some of our work, some of the most important components, our equation, which now I see is also listed on this page, the vertex we found on the previous page, and our goal is to now find the y-intercept. Recall, the y-intercept, or at least the y value of the coordinate representing the y-intercept, is just the constant, or our constant term from our equation. And for us, that value is 4. Of course, the x-coordinate is 0 at any y-intercept. Let me change colors and begin graphing. 4. So we have a y-intercept. Recall we already know our vertex, 3, negative 5. And we know that parabolas are symmetric about the axis of symmetry, meaning 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, really meaning this. Note from this point we could go down 1, 2, 3, 4, 5, 6, 7, 8, 9 units, and to the right 1, 2, 3, 3 units to get to our vertex, meaning that if we continue another 1, 2, 3 units and up 9, we'll get the mirror image. Of course, that could probably be done more quickly and easily just by moving horizontally 1, 2, 3 units to get to the axis of symmetry, and then another 3 units to get to our corresponding point on this side of the axis of symmetry. And now time for a sketch of our parabola. And now for a sketch, and I'm going to try out the con technique of sketching. I'm finding perhaps that's an acquired skill. However, I would say that looks a little bit nicer than what I tried just a moment ago. So there we have the graph representing our equation. And here you can see the book's work to do the same thing, and I think my graph looks more professional than the book's. I assume you agree, but what I am impressed with is, with no photoshopping, basically how lucky I was to have just chosen increments on my x and y axis that seemed to line up pretty well. So anyhow, not to pat myself on the back too much, but it turned out all right. Turned out all right. And your got it question. A, what is the graph of the function y equals negative x squared plus 4x minus 2? And B, a reasoning question. In step 2 of problem 1, why do you think it was useful to use the y-intercept as one point on the graph? So let me take you back to step 2 of problem 1. What we had just accomplished is we had found the vertex of our parabola, and then I suggested, and I may have even given away the answer to this reasoning question, but then I suggested that we could use the y-intercept as our second point. And that's what it's asking. Why did we choose the y-intercept?